It was good. Just continuing on with the speed run of questions from what's it called? Chemical kinetics. These are questions that I haven't done on this series before yet, but the next units will be pretty similar to questions I did in the past. So today we're just going to be working through some more questions. Going to be finishing up this first set of problems. And I feel like these are going to take a bit longer because looking a bit more complicated. So a certain reaction has the following general form. Okay, but why is my pen sticky? At a certain temperature and concentration not equal to 0.200. Most for the experimental data was collected for the reaction. Okay, so we have to find out the order of this reaction. Let me just load up my formula sheet real quick because I do not have that open up. Okay, so we have three different orders that we can have. We got first, second, and third. So now it's saying that plot of ln A versus time was a straight line. Ln A. Okay, so I remember the first one is zero order, second one is first order, third one is second order. So ln A versus time resulted in a straight line. So this would be first order, because here's the formula or the line. So this is a first order reaction, and this is a straight line. So this matches the description of what they told us. Determine the rate law, the integrated rate law, and the value of K for this reaction. Okay, so rate law is just going to be rate equals K times the reactants, and this is first order, so this is going to be to the power of 1. Integrated rate law is just going to be that, what I just wrote here. Schmink. What is the value of K? K, so slope value. Okay, so, bro, wait, how do I even do this? Calculate the rate law. So negative K is equal to M. We'll just call this the slope. So what is the slope? The slope is equal to negative 2.97 times 10 to the negative 2. Therefore, positive K is equal to positive 2.97 times 10 to the negative 2 minutes per negative 1. Or yeah, so there you go. So there you go. That's 1, 2, 3. Okay, that's part A. Part B, calculate the half-life of the reaction. Well, because this is a first order reaction, we could just use T, 1 over 2 is equal to ln of 2 over K. So ln of 2, oh man, I don't have my calculator with me, bro. Frick. I've never said that before. Ln of 2 divided by 2.97. Bro, okay, let's just see if my phone calculator can do this for me. Hopefully it does. Where's ln? Ln 2 divided by 2.97. Where's E? Where's E, bro? Sideways. Oh, okay. E neg. Did I get the right answer? 23.3 minutes. There you go. There you go. That's the half-life. That's simply just plugging into the equation. The only thing that we need to know for this one is just what order the reaction is. But yeah, how much time is required for the concentration of A to decrease to 2.5 times 10 to the negative 3? Well, good question. We just got to use this equation. So this is a first order. So we have this equation. So what is it? T we have to flip it. That's just how logs work. What's A naught? 0.02. Bro, I don't have my calculator, bro. I'm not gonna plug this into my phone, bro. Honestly, I'm just gonna see if... Okay, no, I gotta do this, bro. I'm gonna check one. It's low-key close by, honestly. Okay. Bro, it's too dark in here. 1 divided by 2.97. Bro, I had a psych final today. I can't lie, bro. I did not lock in enough for that, bro. I was unprepared for that. $70.0 minutes. Is that the answer? Yes, sir. There you go. Question 1 done. Let's move on to the next. I only have 3 questions for today, but I think these questions are a bit harder. I'm not sure if these are copyright. That would not be the best. Hopefully I don't get sued by the university, bro. That would be tragic. That would be quite tragic, bro. Yo, imagine if I get expelled for this. Bro, they're probably not watching this, bro. Maybe I'll just put all the videos on private then. A certain reaction has the following general form. At a certain temperature at plot of 1 over A result. Okay. Whoops. So if this is 1 over A plus a straight line. Okay, so if it's 1 over A, that means this is first 0, 1, 2. Okay, this is a second order reaction. So what is the rate law? Boom, because the overall order has to be 2. What is the integrated rate law? It's going to be this. But I would ask ChatGPT if what I'm doing is illegal. I'm actually kind of concerned now. What's the value of K? Well, the slope is 3.6 times 10 to the negative 2. So based on this, K is equal to the slope. And the slope is equal to 3.6 times 10 to the negative 2. So therefore K is equal to 3.6 times 10 to the negative 2. Check if these are right. Yes, sir. Okay, next question B. Calculate the first half-life for this reaction. How do you do that? Okay, so T 1 over 2, 1 over K, A 0. Would we just put this in one time then? I would assume this is right. Whoops. 1 divided by... 9.92 times 10 to the 3 seconds. Yes, sir. Okay, that's the second part. Question C, how much time is required for the concentration of A to decrease to 7.0 times 10 to the negative 4 moles? Why do we need to know this, bro? I don't know, bro. I don't know. Sigh. How much time? Running out of time. Okay, A T minus 1 over A 0 multiplied by 1 over K is equal to T. T is equal to 1 over A to, what's AT? 2.8. Okay, now we just gotta do this with our calculator. I could barely see my calculator at 2.8 e negative 3 divided by 3.6 e negative 2. Oh wow, that's actually right, bro. These numbers are looking mad big, bro. 1, 2, 3, 4. 2.98 times 10 to the 4. Moles. Did I miss a unit? No. Seconds. There you go. That's our answer. Wow, that was actually pretty easy. Okay, last question. Question 9. This Loki looks easy as well. Maybe I'll take that back. Running out of time. Bro, sometimes, like, I just hate when music is so distorted. Bro, where did I go? Where did that go? This unspawned. It's known to be a zero order reaction and have to rate constant to zero. What? Write the integrated rate law for this reaction. Well, if you don't say so. Formula sheet. A T equal negative KT plus A 0. Okay, boom. That is right. Now, calculate the first half-life of this reaction. Well, don't mind if I do. T 1 over 2 equals A 0 over 2 times K. So that's going to be 1.0 times 10 to the negative 3 moles per liter divided by 2 times 0.05 moles per second. What the heck? Is that right? Bro, I really gotta have more confidence in my answers, bro. Because I'm lucky doubting myself. 0.01 seconds. So, KC, calculate the concentration of B after 5.0 times 10 to the negative 3 seconds have elapsed. Okay, well, that's just a simple plug and chug. Multiplied by 5e negative 3 seconds plus bro, it's node, bro. Freaking negative 0.05 multiplied by 5e and negative 3 plus 1e negative 3. Wait a minute. Calculate the concentration of B. How do we do that? Don't we only know A? 7.5 times 10 to the 1, 2, 3, 4. Negative 4 moles per liter. Calculate the concentration of B. What? Huh? Okay, let's try using our brains here. So, concentration of A after some time passes 7.5 times negative 10 times 10 to the negative 4. So calculate the concentration of B after 5.0. Concentration of B. So B is reactant, is a product. I mean, no, wait, what? A is a reactant, B is a product. So A must have react. So so it's 1-to-1 ratio. So that means if 1.0 times 10 to the negative 3 was starting, that means whatever the difference is. What? Okay, wait, 1.0 times 10 to the negative 3, and then we went to 7.5 times 10 to the negative 4. So whatever this gap is, that must be the concentration of B, yeah? Yeah, that makes sense. 1e negative 3 minus 2.5 times 10 to the negative 4 moles. There you go. Is that the answer? Yes. Okay. There you go. That's all. Yep, that's all. Goodbye.